Okay, as we turn our attention to Chapter 2, Section 2, we're going to talk about trig functions of non-acute angles. Now, when we talk about non-acute angles, we're still going to be looking at values in reference to our unit circle, in reference to our special angles, and we're going to be relating them as much as we can there. Now, remember that you need to be working on your unit circle, making sure you know how to build it, making sure you understand what your special angles are. When we talked about how to build the unit circle, we talked about the fact that you really only have to memorize this first quadrant, and then the values in this first quadrant are reflected across your y-axis and down below your x-axis, so that you are just repeating these same values. Every angle that is 30 degrees away from the x-axis, so this angle here in quadrant 1, this angle down here in quadrant 4, then I have 30-degree reference angles over here in quadrants 2 and 3. They have the same trig function values as long as you pay attention to whether they should be positive or negative, those algebraic signs of each value. So that already introduces us to the idea of reference angles. Okay, so a reference angle for an angle theta, written as theta prime, you read that theta apostrophe as theta prime, is the positive acute angle made by the terminal side of theta and the x-axis. When we're doing the reference angle, we are always finding it as a reference to the x-axis. So you're asking yourself, how many degrees away from the closest x-axis? How many degrees away from the closest x-axis am I? Okay, so finding reference angles for each angle here. We are going to be interested in finding where we can refer ourselves to the x-axis. Now, these are not going to give us special angles, but when we move forward, we're going to be using a lot of special angles. Okay, so let's go ahead and start each one of these with a quick sketch. 294 degrees. Well, I know, for example, I know that this quadrantal is 270, so an angle of 294 is going to be over here in quadrant 4, right? This is going to be my angle theta. Well, when I'm looking for the reference angle, that's this distance from the x-axis. That's my theta prime that I'm looking for. One full rotation would be 360, right? So I'm going to say, okay, well, 360 minus that 294, that means I am 66 degrees away from the x-axis. So that's my reference angle, my value for theta prime. What about 883? This is angle of rotation. How many times around can I go? Well, one full rotation is 360, two rotations is 720. So if I subtract 720, I've got 163. So one full rotation, two full rotations, and then I need to go another 163 degrees. 163 degrees, this is 90, this is 180, so 163 is going to be right in here. So this is my angle theta. Theta is coterminal. It is coterminal with 163 degrees. So 883 and 163 have the same terminal side. The reference angle, though, is the distance this angle is away from the x-axis. So it's the difference between 163 and the x-axis, the closest x-axis, which is that 180. So to find theta prime, I'm going to take 180 minus 173. I see that that leaves me with 17 degrees off of the x-axis. That's how far away I am from the x-axis. So 883 degrees is coterminal with 163. Its reference angle, though, in reference to the x-axis, is 17 degrees. All right, let's do the next one. We've got 218. Well, this is 180. This is 270. So 218 is going to be in here somewhere. There's my angle theta. The reference angle is the distance. This angle falls away from the x-axis. Well, it is past this x-axis value of 180. So I'm going to do 218 minus 180, which gives me a 38-degree reference angle. So coterminal angles and reference angles are not the same thing. Coterminal angles are angles with the same terminal side. Reference angles, that tells me how far away I am from the x-axis. Now you'll notice I used different methods to calculate that reference angle. It's going to depend on which quadrant I land in. Over here, I said, okay, how far would it take for me to get to this full rotation of 360? Over here, I added on, or I subtracted it from 180. I did the same thing here. I subtracted 180 from it. That chart gives you, okay, what is the action I'm going to take to figure out this theta prime value? Well, if I'm in quadrant 1, theta and theta prime are the same thing. If I'm in quadrant 2, I'm almost to this positive or this negative part of the x-axis, that is 180 degrees. So my theta prime is going to be 180 minus theta. If I'm down here in quadrant 3, I've gone past that 180 degree mark. So I'm going to take my angle and I'm going to subtract 180 from it. If I'm over here in quadrant 4, I've come almost back around to the positive x-axis, which would be 360. So I will take 360 and subtract theta from 360 to figure that out. You don't have to memorize this chart at all. It's just a good way to help you visualize what exactly we're doing as we are talking about those reference angles. Okay, let's do another example. We're going to find the values of the 6 trig functions for 225 degrees. Alright, well 225, I'm not familiar with 225 off the top of my head, so I say, okay, let's put it on a sketch. Let's put it on our XY coordinate plane. Well, this quadrantal is 180, this quadrantal is 270, 225 is going to be in here. So here's my angle theta, 225 degrees. I need to figure out, okay, well, how far off of the x-axis am I? What's my reference angle for 225? Well, I've gone past 180, so let's do 225 minus 180, and I figure out that that difference is 45 degrees. So this 225 is one of my 45s. Now I know from my unit circle that my 45 degree angles have the same set of coordinates, square root 2 over 2. Depending on which quadrant I'm in, I have to adjust those positive and negative values. But 225 is one of my special angles. It's the 45 degree angle, my reference angle of 45 degrees in quadrant 3. Quadrant 3 means sine and cosine are going to be negative as well as their reciprocals. So the 6 trig functions for 225, sine of 225 is square root 2 over 2. Cosine of 225 is square root 2 over 2. Those are both negative. Tangent's going to be positive though. Anything over itself is just 1. When I flip these to do the reciprocal function values, reciprocal of 1 is just 1. That one's super easy. When I flip this and I rationalize it, because that's what's going to happen, right? So I've got a negative 2 over square root 2 when I take the reciprocal of my sine function value to get cosecant, and then I rationalize that. I get negative 2 square root 2. Square root 2 over square root 2 is just 2, and those 2's are going to cancel and give me 1. Anything over itself is just 1. So I have negative square root 2 for both cosecant and secant. So we find our reference angle, and then we can use what we know about that special angle, if it's a special angle, to find exact values of our trig functions. This is that set of steps. So for those of you who like things to be organized and laid out for you step by step, there you go. You've got a chart on the previous page, you've got the steps lined out there. Let's take advantage and let's use these steps. So we're going to find a coterminal angle if we need to, find the reference angle, and then look at the trig functions for that reference angle and make sure we have the correct signs. Alright, let's divide this up a little bit. So if I look at quick sketches for each of these, negative 150 means I'm rotating clockwise. This would be negative 180, negative 150 is going to be here. There's my angle theta. My reference angle is the difference, the distance I am away from the x-axis. That's my theta prime. So I see the difference between 150 and 180 is 30 degrees. So my reference angle, my theta prime here, is 30 degrees. And I'm asked for sine of this angle. Well, the sine of negative 150 is going to be the same thing as the sine function value for 30 degrees. Sine of a negative 150 is going to be the same as the sine of 30. And my sine function value for 30 is at 1/2. Now, I am in quadrant 3, and sine is negative in quadrant 3. So my sine function value is a negative 1/2. Alright, let's look at B. Cotangent of 780 degrees. Well, wow, so 720 is 2 full rotations, right? 360 times 2 is 720. So if I go 1, that's 360, 2 gets me to 720. The difference between 720 and 780 is 60 degrees. So that 60 degrees is my angle that I'm coterminal with. Since I'm in quadrant 1, that is also the value of my reference angle. So the cotangent value of 780 is also the same as the cotangent value of 60 degrees. And I'm in quadrant 1, so it's going to be positive in quadrant 1. All 6 function values are positive in quadrant 1. So for 60 degrees, cotangent is x over y, yes? Tangent is y over x, cotangent is x over y. At 60 degrees, x over y is 1/2 over square root 3 over 2. Now remember, when we divide by fractions, we multiply by the reciprocals, and by now hopefully you recognize that what's going to happen is that those denominators are going to cancel out. So I've got 1 over square root 3. I need to rationalize it to get square root 3 over 3. Alright, negative 240. Negative degrees means that I'm rotating clockwise. I've got negative 90, negative 180, negative 270. So negative 240 is going to be right in here, right? That's my value theta. The reference angle is the distance away from the x-axis. That's my value theta prime. Well, from 180 to 240, that difference there is 60 degrees. So theta prime is 60 degrees. I'm interested in cosine, but I'm in quadrant 2, so cosine is going to be negative here. The cosine of my reference angle, 60 degrees, is of 1/2. But since what I really have is this negative 240, I'm in quadrant 2, my cosine function value is going to be a negative 1/2 because of the quadrant I'm in. All right, 675. Well, 2 rotations is 720, so this is not 2 full rotations. If I subtract 360 from this, 675 minus 360 gets me to 315 degrees. Okay, so let's see what that looks like. That's 1 full rotation, that's 360. And then to here would be 270. And then I go a little bit more to get to 315. This is going to be my 675 degrees. It's coterminal with 315 degrees. That does not tell me my reference angle value, theta prime. Well, the difference between 315 and 360 is 45 degrees. So I've got a 45 degree reference angle. So I'm wanting tangent of a 45. Well, tangent values of 45 degree angles are either 1 or negative 1. I'm in quadrant 4, which means x is positive and y is negative. So my tangent function value here in quadrant 4 is going to be a negative 1. All right. So if I am moving too fast, slow down, pause, rewind. Go to the My Math Lab multimedia library and look at the My Math Lab videos to go through and see a different perspective on all of these types of examples. When you're doing your My Math Lab homework, click on the Help Me Solve This or Show Me an Example, and again, those will walk you through similar problems with different words, different examples and explanations so that you can find where the things start to make the most sense to you. All right, example 4. We're going to evaluate an expression with function values of special angles. So I've been given special angles. We know things about special angles. We know the sine of a 45 degree angle. We know the cosine of a 135 degree angle, and we know tangent of a 225 degree angle. Now notice this is sine squared of 45 degrees. That's the same thing as taking the sine of a 45 degree angle and squaring it. Make sure you know where that square is applied. So here I have 3 times the cosine of a 135 degree angle that has been squared, minus 2 times the tangent of a 225 degree angle. Okay, so these 3 values are values I know and I can plug in. Sine of 45 degrees, 45 degree angle, sine and cosine are both square root 2 over 2. So this is square root 2 over 2 squared. Plus 3 times cosine, that 135, that's another 45 degree angle. Over here though, I'm in quadrant 2, cosine is negative. Of course I'm going to be squaring it. Minus 2 times tangent of a 225 degree angle. Well, 225, again, I have a 45 degree reference angle. Tangent is either going to be 1 or negative 1. Since I'm down here in quadrant 3, negative over negative is positive. So that is a positive 1. When I simplify each of these, square root 2 squared is 2, 2 squared is 4. So 2 fourths plus 3 times 2 fourths minus 2. Well, 2 fourths is, well, let's just do this. This is 2 fourths plus 6 fourths. I'm out of space going down, so we'll go across. 2 fourths plus 6 fourths minus 2. That gives me 8 fourths. 2 and 6 is 8 fourths minus 2. Well, 8 fourths is 2, and 2 minus 2 is 0. Notice that I do 0 just as a 0. That is the empty set. That is not 0. So make sure that you don't write your zeros as an empty set symbol. Okay, cosine of 120, 2 times sine of 60 degrees squared, and then I have 2 times sine of 60 degrees squared minus tangent of 30 degrees squared. Okay. Pull out your unit circle or a chart. Cosine of 120 degrees, 120 is right here. Cosine is a negative 1/2. plus 2 times sine of 60 degrees, square root 3 over 2, square root 3 over 2 squared, minus tangent of 30. Tangent is y over x. That gives me 1 over square root 3, which becomes square root 3 over 3, square root 3 over 3 squared. So I've got a negative 1/2 plus square root 3 squared is 3 times 2 is 6 over 4 minus 3 over 9. Well, 3 over 9 is just 1/3. So let's clean this up. 1/2, negative 1/2 plus 3/2 minus 1/3. Negative 1/2 and 3/2 is 2/2, which is just 1. So I have 1 minus 1/3, which gets me to 2/3. Okay, couple more examples here. We're going to use coterminal angles to find our function values. We are assuming, therefore, that these are going to be coterminal with special angles. So let's see what we got. 585 degrees. If I subtract 360, I get to 225. So this is going to be coterminal with 225. We've one full rotation, and then we're over here to 225. 225 is coterminal with 585. That's a 45-degree reference angle, right? So theta prime, my reference, is a 45-degree angle. Well, we know if it's sine or cosine of a 45, it's square root 3 over 2. Square root 2 over 2, sorry. Square root 2 over 2. And I'm in quadrant 3, sine is negative over there. So that's a negative square root 2 over 2. Alright, what about B? We are rotating clockwise because it's negative 930. If I go 2 rotations, I am at a negative 210. Yeah, negative 210. So if I am going to rotate clockwise, 360, 720, and then I need to go to 210. So there's 180, 210 is going to be right here. So negative 930 is coterminal with negative 210. That is coterminal with 150 degrees. Makes my reference angle here, theta prime, 30 degrees. So I'm 30 degrees off of the x-axis. I'm at a positive 150, the same place there. 30 degrees off of the x-axis, cosine and sine. I'm looking for cotangent. Cotangent is cosine over sine. So I've got square root 3 over 2 and 1/2. X is negative here. That gives me a negative square root 3 because those 2's are going to cancel out. Remember, the way that happens, it's not magic. Division with fractions means I multiply by the reciprocal. The reciprocal of the denominator, reciprocal of 1/2 is 2. Those 2's cancel there, and I'm left with negative square root 3. Alright, last example, example 6. We're going to find angle measures given an interval and a function value. Okay, so find all of the values of theta if theta is between 0 and 360 and sine is a negative square root 3 over 2. Well, we can narrow this down because sine is negative in quadrants 3 and 4. So I know I'm here. Sine is a negative square root 3 over 2 for which function values? Well, square root 3 over 2 is a value for sine when I have a 60-degree reference angle. So negative square root 3 over 2 is the sine function value here and here. So I've got 240 or 300 degrees. 240 or 300 degrees. And if we want to talk about radians, this is my 3 pi fourths, and this is my, no, this is my, good grief, I'm sorry. I glanced at the wrong location on my master copy, and I wrote it down, and as soon as I said it, I thought, well, that is not right, because we got a 60 degree, not a 45 degree reference angle. This one is 4 pi thirds, or 5 pi thirds. Those are the two equivalent radian values for those degree values. All right, find all values of theta if theta is between 0 and 360. So we're not doing any angles of rotation, just acute, obtuse, and reflex angles, where cosine is negative. Cosine is a negative square root 2 over 2. Well, I know that cosine is negative in quadrants 2 and quadrants 3, and I know that cosine is a negative square root 2 over 2 at the 45 degree reference angles in those values. So if I go 90 and 45 gets me at 135 degrees, and then 180, another 45 gets me to 225 degrees. That's my 3 pi fourths that I was looking at earlier, or my 4 pi fourths. This would be 5 pi fourths in terms of radians.